Yeah, hi, Professor TA and the class of 5810 section 001. Today I am recording this video for the reading assignment 7, and I took the topic a comparative study of automated legal test classifications using a random forest and deep learning. And coming to the summary, like legal test classification is the most popular research topic in the legal field. This classification aims to identify the category of a legal text based on the relationship between the legal text and the category. This would really help the lawyers build intelligent legal systems to overcome the analysis and review of exponentially increasing legal documents and the problems finding the rulings in previous similar cases. A large amount of data for legal text classifications has been collected for US cases and uses deep learning to enhance legal text classification performance. A machine learning algorithm has been used to build high performance legal text classification systems and uses domain concepts as the underlying features and random forest as the classifiers. Like coming to the critical analysis, techniques for legal text classifications are legal text classification refers to identifying the category of a legal text based on the association between the legal text and the category. The tasks for the legal text classification are as follows: law area classification, ruling identification, argument mining, court decision prediction. The legal text can be general and can also be text such as the text from social media and the newspapers, which are longer and followed a complex structure and in turn make the legal text classification difficult. Word embedded for text classification. Word embedding is used for text classification tasks and it captures the semantic information of a text, which is further used for text classification. It represents the word in a low-dimensional continuous space based on the learning of a large amount of data collected, like domain concept extraction and its applications. This method has been developed to extract the terms from the domain-specific information. Domain concept extraction, we generally call it as DCE, consists of 4 steps: extracting terms, filtering terms, ranking terms, and scoring terms. Like model selection and comparison, there were several models proposed for text classification. The models can be categorized into 2 types, like shallow models and deep learning models. Like shallow models, it extracts the features and selects them based on domain knowledge and classifiers. Deep learning models, it extracts the features and does the selection without depending on the domain knowledge. But to note, the deep learning models are not fit for all text classification tasks and are quite expensive. Methodology and experiment design. To develop an efficient machine learning model for legal text classification for US case documents that are of large scale, it includes 3 steps. Document pre-processing, it can be done using the domain concept extraction and feature selection with PCA. Domain document representation, it can be done using word embeddings and text classification. It can be done using classification algorithms. Document pre-processing or domain concept extraction. The domain concept extraction uses 3 steps: term extraction, term filtering, and term by calculation. The term extraction, it extracts the nouns from the legal text. These nouns are used for labeling concepts. For this, we use the parts of this POS dagger embedded in the natural language toolkit NLTK and gave 94% accuracy. Term filtering, the term extracted from the above steps are then filtered to select the relevant terms for a specific domain. It uses the concept of domain persistence DP and the domain consents DC. DP aims to measure the representative of a term in the domain corpus. DC aims to evaluate whether a term frequency appears across the domain corpus documents. The DP and the DC can be combined and term domain scores. The domain score achieved was 68.16 accuracy in the field of economics and 65.16% in the field of medicine. Term by calculation, the combination of frequency and domain score can be used to calculate the term weight. Each legal domain category has its own domain concept. The legal domain categories are medical law, immigration law, insurance law, and family law. The where of domain concept indicates the distribution in the above mentioned category. Feature selection with PCA. PCA stands for Principal Component Analysis. To identify the best effective feature combination, we use the PCA, and it is applied to select the relevant features for random forest. It consists of 4 steps: covariant matrix computation, engine vectors and engine value calculations. On the covariant matrix, feature vector construction, and recast the legal text along principal domain concepts. Document representation word embeddings. Word embedding is used to convert each word in a legal document into a vector, a word to vec, and a glowaway. Are the 2 word embedding models? Apart from these 2 models, there is a word bidirectional encoder representation from transformers model that has the best performance in NLP tasks. Word to vec. It consists 2 learning models which are continuous bag of words, CBOW, and continuous skip grams, so skip, and it learns the words from the local context windows. Glow, it uses the metric factorization method which explores the global statistical information. But it is a word embedded technique that produces the word level representation based on the entire sentence. In other words, the same word may have been different representation if the word appears in different sentences. The text classification algorithm. There are 4 classification algorithms. There are below: random forest, text, CNN, bylong, short-term memory, and stem with attention. The random forest algorithm has been a high performance in the text classification for about 179 classifications with 121 datasets. It create random samples, train the dataset with the model, final prediction using voting. Text CNN. It is a convolutional neural network CNN for text. The word embedded output is given as an input to the text CNN to perform the classification. And Billstem and Billstem with attention are both are similar, and even though the Billstem captures all the requirement comprehensive semantics of the feature vector for both forward and backward directions, all the words do not contribute equally to the correct representation of the document. For that, we need to add an attention mechanism to learn the weights of each word and make important features more relevant. Billstem with attention has shown good results for text classification task experiment. The dataset from Sigma Law was used for legal text classification. It has over 35,000 legal case documents gathered from online repositories which cover 78 areas of law practice. The data pre-processing, document representation, and document classification were performed on this dataset. Results: the domain concept and random forest give the best performance in demonstrating the effectiveness of domain concepts in legal text classification. The highest accuracy was 85.98. The previous was 88.72. Coming to the conclusion, it can be concluded that the RNN models are better than CNN models for the legal text classification task. The domain concept features were more effective than the traditional TF-IDF features in terms of accuracy, precision, recall, and F1 score. Further investigations would be conducted to build a relationship between domain concept quality and the performance of the legal text classifications. This is the conclusion, and we have discussed the result summary and the conclusion with the experiment as well. The questions which I wanted to ask you, Professor, were do we have any other pre-processing methods for document pre-processing, and which machine learning algorithm did author use to build the high performance legal text classification? Because here they mentioned all 4 classification algorithms. But what exactly in particular concluded that RNN models are better than CNN models? Thank you, Professor, for giving me the opportunity, and thank you, class.